In this video, we're going to look at permeability and reluctance. Okay, so let's first of all define what permeability is. So we can express it in terms of our flux density divided by our field strength. So flux density divided by field strength. So just expanding that out, so that we've got permeability of free space. 4 pi times 10 to the minus 7, and then we've got the permittivity, the relative permittivity of the material. So those multiplied together is equal to the ratio of flux density divided by field strength. Okay, so here we've got a typical question. An iron ring, mean diameter 15 centimeters, 300 turns of wire around it, 2 amps, and what we want to do is find the magnetizing force H, and then find the flux density. Okay, so a little bit of rearranging, but first of all, let's find out what H is. So we need to refer ourselves back to the previous video because we haven't got enough information using the current formula to find out H, but we can use. So if you remember from previously that our magnetizing force H is equal to number of turns multiplied by the current divided by the flux path. Okay, so 12,732 amperes per meter is our field strength. Okay, we'll keep that number in our calculator to avoid any rounding errors. So let's work out now what our flux density is. So just substituting all of our numbers. So we've got our flux density divided by our field strength is equal to permeability of free space, which is a constant, 4 pi times 10 to the minus 7, times by our relative permittivity of our iron 200. Okay, so now we can look to do a little bit of rearranging. That gives us an answer of our flux density of 3.2 Teslas. Marvellous. One last thing before we move on, what you can do is you can plot flux density against magnetic field strength. In our case though, how is it quite useful? Well, you could have a question where you have to calculate the flux density, and then reading from a graph, then you could then work out what the magnetic field strength is, and that might be your answer, or then you could then go on from that answer knowing the magnetic field strength to work out, say, relative permittivity or something like that. So if we take this one here, we've got if we've got a flux density of 0.3 of a Tesla there, then that's approximately going to be 1,000 magnetic field strength amps per meter, 1,000 amps per meter. Okay, and that's all. I think we can probably move on from the graph itself. So the last part of this video, we'll look at the resistance to the flow of magnetic flux, which is called reluctance, and it's equal to the formula. So reluctance is equal to magnetic motive force, magnetomotive force, which is number of turns times by the current divided by the magnetic flux. So the unit of reluctance is 1 over the. Okay, then to calculate that out, then we get 17,500 over H. Okay, and that's this video done.